All right, you are welcome again. Today, we want to talk about multiple integral. Without wasting much of our time, let's take a look at this question. Find the value of the integral from 0 to 5, the integral from minus z to z, the integral from 0 to square root of z squared minus y squared of 3 all over 2 xz dx dy dz. All right, now let's go. We're going to take it one after the other. Let's first of all pick the inner integral, which is with respect to x. Okay, that means we're going to evaluate this function first with respect to x. Okay, we integrate with respect to x, and then after integrating with respect to x, we plug in the upper limit minus the lower limit, or the upper boundary minus the lower boundary. Okay, now let's go. When we integrate 3 all over 2 xz with respect to x, it's going to give us 3 all over 2 open bracket x squared z all over 2. All right, we put in bracket from 0 to square root of z squared minus y squared. We have dy dz. Okay, so here we have the integral from 0 to 5 and the integral from minus z to z, 3 all over 2 open bracket x squared z all over 2 close bracket, then the limit 0 to square root of z squared minus y squared. We have dy dz. Now inside this bracket we have 1 over 2 times x squared z. That gives us x squared z all over 2. So this 1 all over 2 inside the bracket, factor it out to multiply 3 all over 2 outside. It's going to give you 3 all over 4. That means we have x squared z remaining inside the bracket. Okay, good. Now let's plug in the upper limit minus the lower limit. You know, when we plug in the lower limit, it's going to give you 0. So that means we are going to plug in the upper limit alone. Okay, so that means as we integrated with respect to x, anywhere we see x, we plug in the upper limit. Okay, so that means we are going to have the integral from 0 to 5 and the integral from minus z to z, 3 all over 4z. In place of x now, we have z squared minus y squared, and then you see that this x is squared, right? Then we have squared times 1 all over 2. Now this square root of z squared minus y squared is the same thing as saying z squared minus y squared in bracket raised to power 1 all over 2, but here we have x squared, and then replacing the x with this square root of z squared minus y squared. That means we're going to have open bracket z squared minus y squared in bracket 2 times 1 all over 2. This 1 all over 2 is the square root, and then the 2 is for x squared. All right, good. Then we have dy dz. Okay, good. So here, when you say 2 times 1 all over 2, that is the exponent. It's going to give you 2 all over 2, and 2 all over 2 is the same as 1. Okay, good. Now let's use this 3 all over 4z to open the bracket. When you use 3 all over 4z to open the bracket, you're going to have 3 all over 4z times z squared. It's going to give you 3 all over 4z cube. And then when you say 3 all over 4z times minus y squared, it's going to give you minus 3 all over 4zy squared. We have dy dz. So here we have the integral from 0 to 5 and the integral from minus z to z, 3 all over 4 z cube minus 3 all over 4 zy squared. dy dz. So here it have reduced to double integral. In this place we have the inner part and the outer part. Again, we are going to integrate the inner part, which is with respect to y. Okay, which is with respect to y. So in doing so, when we integrate 3 all over 4 z cube with respect to y, it's going to give us 3 all over 4 yz cube. You know, we integrated it as a constant because there is no y in it, and then we integrate it with respect to y. So here we're going to have 3 all over 4 yz cube. All right, good. And then going to the second side, where we have minus 3 all over 4 zy squared. When we integrate this, it's going to give us 3 all over 4 open bracket zy cube all over 3. Hello, zy cube all over 3. All right, good. In this place, 3 all over 4 times 1 all over 3 is going to give you 1 all over 4. All right, so here we have the integral from 0 to 5 open bracket 3 all over 4 yz cube minus 1 all over 4 zy cube. All right, and then we have the limit minus z to z, then we have dz. Okay, so from here now we are going to plug in the upper limit minus the lower limit. The upper limit is z and the lower limit is minus z. Now let's go. That means we're going to have the integral from 0 to 5, 3 all over 4. In place of y, we replace with z, right? Good. That means we're going to have z times z cube. Z times z cube is going to give us z raised to the power 4. Then we have minus. We have 1 all over 4 z. In place of y, we replace it with z. That means we're going to have z times z raised to the power 3. It's going to give us z raised to the power 4. Okay, this is for the upper limit, and then we put this in bracket minus the lower limit. Now we're going to have 3 all over 4. In place of y, we replace it with minus z times z cube. Now when we multiply this, it's going to give us minus 3 all over 4 z raised to the power 4. Okay, good. And then we have minus 1 all over 4 z. In place of y cube, we replace it with minus z. Here we're going to have minus z raised to the power 3 times z times 1 all over 4. It's going to give us plus 1 all over 4 z raised to the power 4. Okay, so here we have dz. All right, good. So here, after placing the upper limit minus the lower limit, here we have the integral from 0 to 5, 3 all over 4 z raised to the power 4 minus 1 all over 4 z raised to the power 4, close the bracket, minus open bracket minus 3 all over 4 z raised to the power 4 plus 1 all over 4 z raised to the power 4. All right, good. Now let's open the bracket. You know, we have 2 brackets. Let's open the bracket. So we're going to use this minus in between the bracket to open the second one. So minus times minus 3 all over 4 z raised to the power 4 is going to give us plus 3 all over 4 z raised to the power 4. And then this minus times plus 1 all over 4 z raised to the power 4 is going to give us minus 1 all over 4 z raised to the power 4, right? Good. Now here we have the integral from 0 to 5, 3 all over 4 z raised to the power 4 minus 1 all over 4 z raised to the power 4 plus 3 all over 4 z raised to the power 4 minus 1 all over 4 z raised to the power 4, close bracket, dz. Okay, so this term that we have, they are all z raised to the power 4. They are all z raised to the power 4. Now, it's the same thing as if we pick the coefficient and add together. It's still the same thing as adding them. Okay, so picking their coefficient, that means we're going to have 3 all over 4 minus 1 all over 4 plus 3 all over 4 minus 1 all over 4. So when you say 3 all over 4 minus 1 all over 4 plus 3 all over 4 minus 1 all over 4 is going to give us 1. So that means 1 times the z that we're talking about. We have z raised to power 4, right? Good. So that means when you evaluate this 3 all over 4 z raised to power 4 minus 1 all over 4 z raised to power 4 plus 3 all over 4 z raised to power 4 minus 1 all over 4 z raised to power 4. When you evaluate this, it's going to give you z raised to power 4. Okay, so that means here we have the integral from 0 to 5 z raised to power 4 dz. All right, good. Lastly, we integrate with respect to z. When you integrate with respect to z, you are going to have z raised to power 5 all over 5, and then the limit from 0 to 5. Let's plug in the upper limit. That means we are going to have 5 raised to power 5 all over 5. So 5 raised to power 5 all over 5 is the same as 5 raised to power 4. Then 5 raised to power 4 is 625. So the solution to the multiple integral, the integral from 0 to 5, the integral from minus z to z, the integral from 0 to square root of z squared minus y squared of 3 all over 2 xz dx dy dz is giving us 625. All right, yes, thank you very much for watching. Please let's take more examples. Please, if you are new to our YouTube channel, like, subscribe, share our videos, and stay blessed.